everyone, and thank you for coming. Thanks for the great introduction. I didn't expect standing applause. So today I'll be talking about the shoulders of giants, the languages Kotlin has learned from. And I'm the project lead for Kotlin. I worked on the language design since 2010. So it's kind of a summary of many interesting experiences in language design. And I'll be taking questions during the talk, just calling for questions in the middle. So if you want to ask questions, you can move to the front. Will also make me more comfortable, having some people right in front of me. But it's not mandatory. So as an introduction, I want to explain why I'm giving this talk, why I want to do this. And the main reason is this. So people fight. People fight in many contexts. People fight a lot on the internet. And people fight a lot about technology and programming languages in particular. And one of the arguments that makes me kind of puzzled every time is, oh, this language you like has stolen all the ideas from that other language I like. Every time I see this, I'm kind of like, stolen? What do you mean? And of course, any language created, and Kotlin is no exception at all, is using ideas from existing languages a lot. This is how progress works. We look at what exists, we see how it works, we take what we like, put it together, rehash it very much to shape it into a new language, and offer you to try. And so if it's a good attempt, you like it, and the progress may move that way. If it's something is not a good idea, we backtrack and try something else. Right? So this is how it works. But people keep accusing each other of doing this. Or actually, they are accusing each other of liking something that has been created this way. And I think it's very, let's say, counterproductive. Because it's discouraging the idea of building up on other people's work, which is counterproductive. It basically blocks progress. So if we label this as bad, as immoral, we'll be stuck, right? Everybody will have to invent their own very original programming language. And then everybody will have to program in that, which is probably not a great situation. So I would like to, let's say, to openly admit that we've been building up on other people's ideas, to say thank you, and to encourage everyone to do the same. So one important thing is that what you are looking for in a programming language is not originality. Using an original language that took no ideas from previous languages doesn't make you productive. It doesn't make your projects great. It only makes it harder to learn. That's it. So my goals here is, of course, to inform you about Kotlin, and then make it clear that using existing ideas is good and normal, and please use my ideas if you like them, and let me know, I'll be pleased. Also, it's kind of a call to my fellow language designers to come up on stage, different conferences, and tell the same. It will be very informative. I would attend those talks, and will probably change a little bit the perspective in the, let's say, general public about the, like how the languages are created. So, what do you think? What languages has Kotlin learned from? Say it again? Python, OK. Anything else? Java, Scala, Swift. OK, let's try to pick the language that Kotlin has learned from the most. Java. Thank you so much. Yeah, I agree there. So the only one that we haven't learned much from this list is Swift. Unfortunately, we didn't know that Swift existed when we started Kotlin. It was announced a little later. I would love to have had access to Swift's design when Kotlin was conceived, but I didn't. Otherwise, yeah, Java is our biggest inspiration. And if you look at it, it's so many things we're using, of course. We have classes, of course, classes and interfaces. A class have a single superclass and multiple super interfaces. We have constructors, we have nested inner classes, annotations, so on and so forth. And it's like, you can tell that we were looking into Java, and we were actually building for the JVM as a platform from the very beginning. But also, like language design, many people say that language design is not so much about what you take into the language, but what you leave out. And of course, today I'll be talking not only about things we took, but also the things we didn't like and didn't take. So for Java, it's very many things. And it's like we didn't take monitors in every object. We didn't take the finalizers, raw types, static methods, and fields and properties. Primitive types in Kotlin are classes, unlike Java, so on and so forth. So it's many things that we wanted to improve on, and some of them we actually did. So let's have a look at the first example. OK, so what language does it look like the most? What do you think? Oh, I have no pointer. OK. What language does it resemble the most to you? C#. Yeah, it actually does to me as well. So although the concepts themselves, the classes, the inner class, the single inheritance for implementation, so on and so forth, were taken from Java, the Kotlin syntax, I still don't have a pointer, sorry. The Kotlin syntax there shows you the C#, some of the C# heritage. We also don't distinguish between extends and implements lists. So it's kind of a blend in syntax in what we've taken from Java and C#. And another difference from both Java and C# is the inner class syntax. So in Kotlin, you can have a nested class if you just write something inside another class. Or if you want to capture the outer instance, you say inner explicitly, because we want you to know that you're capturing something here. It has memory implications. So we turned this around. So the idea comes from Java. The syntax is flipped around. And C# doesn't have inner classes at all. There are many more classes, many more features we took from other languages, like Scala and C#, for example. So if you look at this one, there's many interesting things, right? So it's a class that has a constructor. And right there in the declaration of the class, we have constructor parameters, one of which is marked val, which means it's also a property. So it's not only a constructor parameter, but also a property. And right there, you can call the superclass and pass the arguments. All these ideas come from Scala, including the val keyword, which I'm very grateful for. Then the rest of it is a little bit of a blend. Right, so in the body of the class, I declare var, a mutable property, with a setter. And it's not quite Scala, it's not quite C#. It's our original, let's say, syntax, where you don't have any curly braces around the setter. But it has the internal visibility marker, which clearly comes from C#. So we could use the idea of internal visibility, which means you have a module which contains many classes, and those classes can see each other's internals if they like. So it's not package private, but like module private. Unfortunately, our runtime, unlike the C#'s runtime, does not support us there, so we have to emulate this. But the idea has proven very useful, so we're keeping, and thanks to C# for this idea. Also, the override keyword, being a keyword in the language and not an annotation like in Java, comes both from C# and Scala. And the fun keyword, which we're particularly proud of, actually doesn't come from either of those two languages. Who knows which language it comes from? Python? Python has def, as far as I remember. OK. It's normal. Industrial programmers are not supposed to know this. This actually comes from the ML family of languages. So I think the original ML had fun as a keyword. This is a very controversial language design point. Like, people argue a lot. You know, some languages say function. Those languages also say many other weird things, so we don't learn from them that much. Some languages say func. Some say fn. And there is this option of fun, which is a 3-letter word. And the Russian part of the audience knows that Russians love 3-letter words. So our vals and vars are already 3-letter words, so we used fun to align the declarations nicely. Also, having fun is what we all like. And with the new developments in Kotlin, by the way, you can have, we have expect and actuals for multi-platform projects. So you can have actual fun, or you can expect fun, or you can have public actual fun, or private actual fun, so on and so forth. So it's been a good pun-making stuff for our marketing and presentations. So this example is not from Kotlin. So my slide ID doesn't recognize it and doesn't highlight your keywords. What language is it? Python. Oh, OK. There's this very interesting misconception that Python has curly braces. It doesn't. Yeah, so this is Scala. And it's actually one of the things I was quite surprised about when I first read about Scala, is how the properties work there. So here we basically declare a property with the getter and the setter. But the syntax is quite interesting. So the setter is a function with a suffix underscore equals. It's kind of the same of saying set name in Scala. So we didn't take that. Another thing we didn't take for properties is this. This may be more recognizable. What language is this? C#, yeah. So C#'s approach to mutable properties is having extra curly braces around every property and having get and set nested there. We were kind of, oh, that's too many curly braces. My right hand is kind of tired of doing this, so what we did was this, and it's similar to C#, but kind of a little cleaner. OK, so what else did we? So what we did leave out from, say, Scala was interfaces versus traits. It's a very controversial topic. So Scala has this concept called traits. And the computer science literature has a lot on traits. And many languages, including dynamic languages, have things called traits. And nobody can agree what a trait is. It's like anything. But basically, the idea was to somehow escape the curse of single implementation inheritance and somehow to inherit method bodies from more than only one class. So Scala's approach was to have this thing like interfaces with methods and even with fields. So Scala allows state in interfaces and then figure out the multiple inheritance problems. So Scala's approach to figuring out multiple inheritance was at the time to not have any constructors in the traits, which means your properties are basically, let's say, they cannot depend on any parameters outside, right? So this leads to, like, the constructor is still there. Like, there is a method body, but there are no constructor parameters, which means constructors are executed and they have effects. So you have to have predictable semantics for, like, when the constructors are executed in what order. And we were kind of scared of all that, so we scrapped the constructors. For some time, it was still called traits in Kotlin, but then Java 8 design came along, and we saw that something very similar is called interfaces in Java, and we simply renamed that to interfaces. So now Kotlin has interfaces with method bodies, without any state, no constructors, no linearization, and we're quite happy about that. At this point, do you have any questions? Oh, that's a scary silence. All right. OK, I'll just go on. Actually, questions are simply making me feel better. I feel like you're actually listening and not just, chilling out. OK. So some more differences between Kotlin and other languages. So if you look at this one, there's many interesting things going on the slide. It's a class where the primary constructor takes one parameter of type some interface. And then I want to implement the same interface. And what I often do in my code, I want to delegate my implementation to that instance that I took as a constructor argument. Right? So in Kotlin, I can do this in one short keyword. So I can simply say by D, which means compiler, please generate me all the methods delegating to this interface. So we use this as a language feature. It's actually a byproduct of the initial idea of having a proper multiple inheritance in Kotlin, which died very young, but left this as heritage. So we had this ambition of figuring out multiple inheritance once and for all, being better than C++ there, so on and so forth. It actually turned out that C++ was doing quite a good job there, and it's not easy to do it better. So we definitely didn't take that. And like the best we had there is this delegation. It's not the feature I'm most proud of because it's problematic in terms of interactions with other language features. So it's one of those I would really like to reshape somehow for the future language versions of Kotlin to kind of make it play nicer with other language features. But still, it's there. It's useful. We appreciate it. Also, what's the difference with other existing languages is the init block. So if you want some code executed to your primary constructor, Scala, for example, allows you to write it just in the body of the class. Just say curly brace, opening curly brace of the class right here, and then print line at the top level of the class. That's nice. It makes some Scala classes turn into basically scripts. But it's not easy to parse and maybe cumbersome for many other use cases. So we decided we want explicit demarcation for the constructor bodies. So we have init there. And then the rest of it is kind of usual. We have default method primary values. You can have named arguments. All this exists in C# and Scala and this or that form. No questions? OK. All right. And another example. If I want to create an instance, and like normal instance, I just call it like this, right? So I say, here's my person, and the person class, and its constructor is called like this. What's odd about this line? Not Java or Scala-like or C#-like. Yeah, there's nothing new in this line. Although, actually, it is creating a new instance. It's just that we were looking at the code, at the grammar, more or less, and was like, oh, the new operator is not really needed in Kotlin. Why don't we get rid of it? Like, we don't need it. It was a bit scary. There was an argument that, OK, maybe it's good to actually label where the new instances are created in the code. But then Python came along. I mean, it didn't come along itself, but somebody who knew Python well told me that, OK, but Python doesn't have new. So what do we care? Like, people don't suffer there. They seem pretty happy. And now we're happy. We don't have the new keyword. We can create new instances with something that looks more or less like a function, which also created this pattern in Kotlin when you can overload the constructor with top-level functions and have, like, let's say, extension constructors. But also, it created a problem. We couldn't reuse the anonymous class syntax from Java. So in Java, you can say new foo, and then curly braces to create a new anonymous subclass of foo. In Kotlin, you can't because you don't have the new keyword. So having the hard keyword, the new, just for the sake of this single use case was kind of an overkill. So we used another keyword, which is object. So to create a new anonymous object of this class, you say object base, which creates basically an anonymous subclass of base, and here goes your class body. So this is because we have singletons built into the language that are marked as object. Those are named, so these are anonymous. So you can create many instances of these. These are not singletons. But if you have a named object, it's a singleton. And this is borrowed directly from Scala. It's all the same concept. So singleton is both a class and an object. You can use it as either. You cannot create new instances of it. And that's about it. So thanks, Martin, for this idea. But then there was another concept that kind of continues this line of thinking, which is companion objects. It's also coming from Scala. The thing is, if you want to do kind of pure object orientation, statics as an idea kind of are nailed on the side because it's very, it's kind of unintuitive. What does it mean to have something inside a class that is not a method on instances of the class? So Scala has this pretty straight. They don't have any statics, and we like this. So nobody creates, say, a string util class that's full of static methods, which means it's not really a class, it's just a bag of methods. Right? We have top-level functions. You don't need to create a class to just expose a function. So we wanted to get rid of all the statics after Scala. And Scala has this interesting idea. Like if I have a class foo, and next to it, in the same file, have an object foo, then methods of that object are kind of static methods in that class. Like you can say foo dot something, and it will be called like this. It's called companion objects. We liked the elimination of statics, but didn't like the syntax. It's like I'm duplicating the name. I have them like one in the beginning, the other in the end of my file. It's kind of flimsy. So let's put it all together. So we put companion objects inside the class. Right here, I can have my data as a class name, and companion object right here, and the factory method that creates an instance of that class. Then I can use my companion object just by the name data. This is my initial goal. But also it creates an extra level of indentation, and many people don't like this, so it's the second hated feature in Kotlin, I think. I don't know how to get rid of it easily, but I definitely plan to improve this somehow in the future. In any case, again, thanks to Scala for the idea of how we can get rid of statics, albeit didn't work so well for Kotlin. By the way, the statics can't be practically eliminated because people want statics, right? You want to interface with Java. You want to expose something as a static method to the Java code. And this is how we start tweaking the Java API of our Kotlin classes through annotations like this. So you can say that this is supposed to be static for the JVM. Any questions here? Yeah, so when I said, yeah, so sorry, I'll repeat the question. Question was, if companion objects are the second most hated feature, what's the first most hated? I think by the language designers, by our team, the first most hated feature is delegation, class delegation, because it's very difficult in interactions with other things, like default methods, for example. And the second problematic thing for us is companion objects. Thanks for the question. Any more questions? Yeah.
Constructor keyword on the slide, because this doesn't look like valid Kotlin to me.
Did I miss the constructor keyword? Oh, I probably did. Yeah, thank you. Yeah, I have my ID right there in the 6th row. Thanks, Dima. OK, so yeah. I already mentioned that these two were not so great ideas, and we'll probably improve on them somehow in the future. OK, so more examples of what we took from other languages. If we take CSharp, here is what's coming from CSharp on this slide. it's extensions. Extensions are very important. So this class is normal. It doesn't come from, it comes from Scala more or less, all the syntax there is. But this is actually one of the most successful features in Kotlin. It's kind of a weird function that has a dot in the middle of a name, which is actually supposed to mean that it's a function that's kind of looks like a method of this person class here. So it's supposed to behave as a member, although it isn't. It's not scoped inside the class. It's outside. So the point here is I can add a method to an existing class without changing its source. A good example would be string, right? So somebody in OpenJDK writes a string class. And I really like to have some nice, convenient method for this, like break into words or something. But I don't control the string class, right? Like here I can pretend that I don't control the person class. And I want to add a method, a convenience method that makes my life easier. But I can't go into the OpenJDK, add a method, recompile the world, redeploy the world, just for the sake of having this one method. Right? So in Kotlin, you don't have to do all that. You can simply say, OK, I have my extension for the string class. So it will be string.fullname, or yeah, strings don't have full names. String dot break into words. And it's compiled to your beloved string-util class with the static method in it. But from the Kotlin side, it looks like you're simply calling a method, which is a very important addition to the normal OOP thing. So this has been popularized by CSharp. They have a slightly different syntax, which is here. So CSharp has it this way: public static string full name, and then you just prefix something with this keyword. So it says, now this parameter is actually your receiver, and then you can call it with the dot. So Scala has it in a slightly different way, and we were quite scared by how it works there. Scala is altogether very big on implicits, the idea of things can happen implicitly in your code without you knowing, which I'm personally, as a control freak, is very nervous about. I have a history of debugging one line of Scala for 40 minutes before I could figure out what it was doing because of so many implicits. So in any case, Scala's approach at that time was that you had this thing called implicit class, which says if you have a person, it can also be automatically wrapped by the compiler into a rich person. Don't we like to be wrapped into rich people? And that extra class will expose an extra method that you can call as an extension. So the wrapping part is scary because it's an allocation. Now Scala has got rid of allocations there, so it's performance-wise as clean as Kotlin or C#. But still, they, as far as I understand, they currently use classes to express the idea of adding a method on an existing API. So we try to simplify all this and just use the full name, well, not full name, but just extension syntax, like right here. Questions? The question is, can you abuse this feature to override existing methods? Thank you so much. Hackers in the room. No, the answer is no, you cannot. So the way the language works, if you have a member that's applicable to whatever arguments you're passing, the member will be called and the compiler will not consider any extensions. If the member is not there, the extensions will be considered. And also, extensions are scoped in packages, so if you do not import your extension, it's not applicable in your code. So you have some control over what extensions are available there in any particular file. More questions? Mm-hmm.
Can you break encapsulation by this?
Thank you so much. Another hacker in the room. People who like breaking things. Not really. So I think what you might mean by break encapsulation is whether I can access privates. The answer is no, I cannot.
Oh, the question is that you can return something and then you can use to break into the inside of the object inside. Like if it's talking about Java, it will be date, for instance, and you can then in here person return date, and then you can go into this date and change something inside.
Well, when you say break encapsulation, you need something to be encapsulated in the first place. So to encapsulate something, you need to mark it private.
Yeah, you mark it private, like for the date and.
All right. Yeah. So let's imagine that one of my fields here is private. It wouldn't be accessible from this method because it's outside the class. So nothing outside the class can access my privates, including extensions. My extensions cannot expose.
But you can return it. Yeah. Here you can add additional function like return the date, and it will be exposed. Yeah. And if you are so.
Well, let me try to get it straight. So if my class exposes any of its private somehow, like I have a private field and another method returns my private, it's already exposed and it's not encapsulated. So extensions cannot help you there anyhow. They can only build on the public API of the class. So anything that extension is using is already public. You cannot break encapsulation by this. You can compromise your encapsulation by just publishing something that was not supposed to be public. That's up to you as the author of the class. More questions? OK, let's move on. Now it's Groovy time. This is very nice syntax on the slide, which tells me that Groovy allows me to take a collection, for example, then filter and map it, and use the it as a shorthand. And this is also valid Kotlin. I believe the same exact syntax works in Groovy, and we liked it very much. We wanted it in Kotlin. So this is actually a mix of many features, but the basic ideas here is lambdas don't have to be passed inside parentheses if it's the last lambda on the list. So if you only take a single lambda, for example, you just say curly braces, and that's it. And also, if your lambda has only one parameter, all you need to do is use it by the name it. You don't have to declare it, which is also making things very short. So thanks a lot to the creators of Groovy. It's been a pleasure borrowing features from you. Other languages have this differently. And guess which is which. I'm not asking you which language this is. It's quite obvious by the number of characters. But what are the others? Yeah, so the first is Scala, the third is CSharp. So the Scala's approach is quite interesting. So Scala has, or at least used to have, this interesting syntax where you can say underscore, which means that, first of all, it means that this is a lambda already, suddenly, and also that this underscore signifies the only parameter of this lambda. So when I was writing Scala, I was quite often lost in whether I'm in a lambda or not because of those underscores conspiring against me. So I was kind of scared of all that. And in Kotlin, we have the discipline of every lambda has curly braces around it. So if you have a lambda, it will be demarked by curly braces, period. There is no magic. And C# and Java both have this syntax with just arrows, which is a fair middle ground, but we like the conciseness of just saying it without declaring anything. So here we know it's a lambda by the curly braces, and then we can infer the it from the context. Questions? All right. So something that's not in Kotlin yet, but may get there at some point, is actually largely inspired by C# and Scala, and is a bit present in this slide with the where and select. The interesting name choice for C#, because the C# syntax is inspired in some way by LINQ and thus SQL. All this is called collection comprehensions. Scala expresses it as for loop on steroids, when you can yield things from the for loop. So it creates a nice environment for collection traversal. C# exposes it as XML. Python exposes it with transposing many keywords, and actually many functional languages do a similar thing. So comprehensions are kind of a controversial feature because people like them for their conciseness, but they don't actually save too many characters compared to the Kotlin syntax. But the language implementers like them for their syntactic difference, where you can, so basically this simply combines filters and maps. But when filter and map are two separate functions, they execute two separate loops. If it's not lazy evaluation, if it's eager evaluation, I have to run one loop and then the other loop. There is an optimization called loop fusion, which can eliminate the intermediate collection. So I don't have to put the results of my filter into a single collection and then use that from a map. I can just fuse the two loops. Right? The problem is my conditions, my lambdas, can have effects, and I can't do this optimization on the function calls. But I can, if it's a different syntax, if it's comprehensions, it will be all very nice and fused. So this would be one of the reasons to add comprehensions to Kotlin, but we don't have any particular plans to add this at any given time, but we're considering it. So the people who are responsible for bytecode optimizations in Kotlin are pushing for this very hard. Questions? All right. So yeah, another part of the Groovy time is this. It's actually kind of a hello from the Pascal times. I started in BASIC, but my most interesting programs I wrote as a school kid were in Pascal. So Pascal had this very nice feature that Groovy can also express, which is called with. When I have the luxury of not repeating this foo name here, especially when it's a long expression, and just say, with foo, do all these. That's very convenient. And it's the most basic example of what we call a builder, and Groovy calls it a builder as well. So the idea there is that you basically import an object into your current lexical scope, and you can use the methods of that object without qualification. That's nice. Groovy, at the time, in 2010, had this only as a dynamic feature. It was heavily dependent on the dynamic capabilities of the Groovy closures, and we really wanted the same thing, but statically typed, because Kotlin is statically typed for many reasons, like safety, tooling, so on and so forth. So we wanted to, without having a separate feature in the language for builders themselves, to somehow combine the existing language features to get something like this. And actually, we can get more. So this is the result of this borrowing on the Groovy inspiration called type-safe builders. We can express something very similar to HTML in semantics. I have my anchor link with a reference to this website and an image inside. It's a type-safe builder. It's actually a combination of many features. It has lambdas and the Groovy syntax for the dangling lambda on the outside the argument list. It has extensions, because this lambda here is actually an extension function. And this is why it exposes the this reference without qualification. And of course, it uses function types and the Kotlin's discipline for static typing for functions. So all this blended together gave us type-safe builders. It was quite nice. It was probably the first original invention at the time, so we didn't invent anything that other languages didn't have in any form before, and this was the first such invention. Questions? Yeah, this being kind of an invention, it still was heavily inspired by Groovy and the need to declaratively express things. Okay, another puzzler. What language is this? Speaking of DSLs. Any guesses? Looks like BASIC, but actually it's Scala. And what surprises me the most is that it's actually up on the Scala documentation website. It's an example of how much you can twist a language to make a DSL. So Scala is flexible enough to express something like this, right? You can do quite a lot of things. Especially, you can introduce your own operators like this. Scala doesn't have a colon equal, but you can introduce one. And in Kotlin, we deliberately decided we don't want this flexibility. So we're flexible enough to have DSLs like this, structural, declarative style of nested trees and builders. But we don't want this kind of flexibility when you can override anything. You can invent your own very interesting operators of weird characters, so on and so forth. So these are the things we deliberately left out. And so far, we are pretty happy with that. Although, of course, there always are people who want us to add this one operator to express this very interesting DSL here and there. So we're kind of trying to balance the needs here. Still, it was quite interesting to learn Scala and understand how all this works with the flexibility. It was quite inspiring. OK, another thing that comes from Scala as an idea is data classes. It's actually something we didn't add at the very beginning, but then people start coming and asking for this functionality exactly as they have it in Scala, which basically means people don't want to write all the technical stuff that JVM requires, equals hash code and toString, which are very often needed for reasonable usage of the classes. And also, we added a few things that are convenient for Kotlin, specifically component functions to do things like this, the structuring and the copying of your data class with some changes of the structure. So this has been directly borrowed from Scala. It's called case classes in Scala because of this syntax. So Scala actually introduced this, I think, originally for the sake of pattern matching. Kotlin doesn't have pattern matching as such. We so far think that pattern matching is too heavy a feature, even though Java is gearing up to have pattern matching at some point. We'll still look at how it works for them and only then try to introduce it. By the way, it's always very nice when someone else tries a feature for you, because of course, people are usually proud to be pioneers, and like we were proud to figure out the type safety for builder DSLs. But it's actually a lot safer when CSharp tried extension methods for us first. Or Java is going to try the pattern matching if they, get there at any point. So we're kind of cautiously waiting there. So in Scala, what we call data classes were called case classes because the primary use case there is the match operator and the case prefix for the classes. So they want to match against this. Kotlin has something actually very similar, and I'll show you in a minute. But the overall concept is useful outside the pattern matching, so we have it called just data classes. And what's similar in Kotlin, though still not pattern matching as such, is based on another idea that's borrowed from a language not so well known, which I don't remember which it was. Unfortunately, it was many years ago. So I'm not sure if it was the nice language or the Gosu language. But they had this idea of flow-based typing. So the basic logic behind it is that you don't, very often in code, you don't need an explicit cast. Because usually you cast, if you're disciplined, you usually cast only after having checked that the cast is possible. There is no point in saying, oh, if my X instance of something, then cast this to something and only then use. So we just leave out the cast part because the compiler already knows that something has been cast. So is instance of, thanks to C#. And so when something is a person, we can just use it as a person. If it is a pet, you can just use it as a pet, and there is no need to cast explicitly, which turns our ifs and our whens, which are the closest to switch case, to something almost as good as pattern matching. It's not exactly pattern matching because you cannot match on the structure, but it covers, I don't know, maybe 80% of the cases and has been working fine. So people, let's say, people do still request pattern matching, and they mostly are from two groups. Either it's the lovers of functional programming that are just used to having proper pattern matching on structure, or they're compiler writers. Compilers have to work on trees a lot, and the actual matching on the structure is very relevant. So there is this small lobby of pattern matching lovers that want that in Kotlin. But I'm still resisting. I'll wait for Brian and the team to try this first. Any questions? Yeah, there is a mic behind you.
Related to the data classes, you mentioned that component 1, component 2, and so forth methods were added to the classes to do basically destructuring. For this. The last line, yeah. I have a question. Why don't you use something similar to ECMA 6, which also has destructuring, but instead of having this component 1, component 2 members, they would use the field names of the destructurable object for that purpose.
Thank you. So the field names, there is a big difference actually, because if you think of, for example, pairs, right, or tuples of any kind, you have a pair class and has the fields or properties first and second. If you're bound to have your variables always called first and second, you can't reasonably use these. ES6 has the syntax to rename those, but you still have to mention the first and second, which is kind of inconvenient. Also, the component convention enables many other interesting things. Like you can, for example, on a list, you can have component 1 as first and component 2 as tail. Or like component 1 and 2 and 3, or whatever you like. So it's more flexibility than just fields. So the way JavaScript has it is more or less influenced by the philosophy of JavaScript, which is just a different philosophy from Kotlin. Thanks for the question. Any more questions? All right. So a little more examples. We're going down to the expression structure. So these are the niceties we borrowed from Groovy and CSharp for the sake of nullable values. So Kotlin has the discipline for nullable types, which has been tried before in CSharp with quite a different design. So we built it more into the type system than CSharp used to. And we wanted shorthands for very common nullness operations because they make things a lot more concise. So this thing here is called Elvis operator. We took it from Groovy. I don't know who pioneered this. So it's read or else, right? So normally you have a ternary operator, which we don't have in Kotlin. We'll probably implement it at some point. But we don't have a proper ternary operator, but we have the shorthand. Like if the left-hand side is null, then use the right-hand side. So it's like a default value. Also, we have the safe call, which is if the left-hand side is null, do not try to dereference here and just evaluate to null altogether. And then you can use a default value if you like. This one, though, the double exclamation mark, is a not null assertion. And it's, as far as I understand, not borrowed from anywhere. So it's an operator that's deliberately annoying. So it was designed specifically to stand out in the code and inform you that you're doing something dangerous here, because what it does is it throws an exception if the nullable value here is actually null. So it's designed to say, look, here is a dangerous thing going on. So this is why it's not a single exclamation mark, but a double, just to make it stand out. Also, a single exclamation mark is too precious. We're still keeping it for something else. Yeah, and also the casts are directly borrowed from C# as and as question mark. And the annoying parentheses around are kind of a deliberate decision that we're not going to make casts very convenient, because casts are bad and you don't want them in the program anyway. Questions here? Okay. The last bit, I believe, is about generics. So generics are kind of an interesting story because more or less many languages have them from, and the syntax, more or less the idea of the syntax originates from C++. But then there is so many variations. So this syntax we have here is actually a blend of Java, Scala, and C#. Because like Scala, for example, we have variants. When you can say that my class only exposes my t as an out parameter. So I only return t's from my class, which makes it play nicely with inheritance. Very good, but Scala uses plus for that. They say plus t to indicate that it's only put out. So C# has a nicer syntax there, or at least more appealing to me, which is saying the word out explicitly. So we borrowed that. So the semantics come from Scala. Scala is a little more uniform. So C# only allows this on interfaces. Scala does this on classes and interfaces alike. So we use Scala semantics with C# syntax for out if you are returning things, in if you are taking them in. And then you can blend the two and have both. But then on the call side, if you have, so actually if you are taking things in and out at the same time, you get the Java semantics of generics. And you probably know that if you, in Java, if you have, say, a list of object, it's not a supertype of a list of string. So you can't simply pass a list of string where the list of object is expected. And you're supposed to say something like question mark extends object, which many people struggle to understand. So we shortened this a little bit for the sake of Java interop and for symmetry. So at the call side, you can say out t and in t, which means question mark extends t or question mark super t, the same as in Java. And I believe Kotlin was the first mainstream language to introduce both use side and declaration side variants. So this kind of advanced generics trickery we combined first. And it wasn't easy, but we got some help from academics. Ross State helped us design this, and thanks to him. Questions here? No questions. All right, so this was my last example. The big takeaways from this talk is A, borrowing ideas is good. If you notice a good idea in this talk, go and use it in your language. Please, this is what we should do. And if you already use some existing ideas, be proud of it and spread the word. Thank you very much for your attention.